Hi guys, welcome to another interesting session of my project ideas. Today we are going to have a look at the chapter Natural Number Sum Using Recursion. So what do we do here? In the last chapter we learned about tail recursion. Here we are going to have a look at finding out the sum of the natural numbers. By which method? By using recursion. So let's have a look. What does this statement means? Suppose you are given a number n. Suppose we have been given a number 6. We have to find out the sum of the natural numbers till 6. Like 6 plus 5 plus 4 plus 3 plus 2 plus 1, which gives us 21. If your input is 3, you get the output at 6. How? 1 plus 2 plus 3, that is 6. If your input is 5, you get the output 15. How? Just sum the numbers from 1 to 5. For this natural number sum, the iterative approach is actually the better approach because it takes a constant time period, that is big of one auxiliary space. It takes big of one auxiliary space, not a time period. It takes constant auxiliary space, but the time complexity will be big of n. But in case of recursion, what happens is the time complexity becomes big of n, which is same as the iteration approach, but the auxiliary space is big of n because we are going to use the recursive call stack. Got it? So now what we are going to do is we are going to have a look at the code and I'm going to show you how does the code look like. Let's create a new file and let's name it natural number sum. Natural number sum using recursion. Simple.python. First, what we are going to do, we are going to create a function that is def recur sum. We are going to take this parameter n here. Then, if n is less than equal to 1, we are going to return n. Next, let's see, return else return n plus recur sum n minus 1. Then if we have n is equal to 5, let's take the input as 5 and let's, okay, let me save it. What's the output? You guys already, I think you already know it. The output will be 15 because 1 plus 2 plus 3 plus 4 plus 5. So I hope this was interesting. I hope you understood this code. I hope you understood why we use recursion and why the iteration approach is better in this case. And you got to know the time complexity and auxiliary space complexity. You got to know how recursion can be used. So let's wrap up this session for today. In the next session, we are going to have a look at some more interesting topics, some more interesting ideas. With this, I take your leave. Bye-bye. Take care. Keep learning.